Let's be honest. Have you ever stopped for a moment in silence and asked yourself, what am I? Not your name, not your job, but that inner sensation, that awareness of existing that is living this precise moment. This question, so simple and so intimate, is the gateway to one of the greatest mysteries that modern science faces today. A mystery so profound that it forces us to reconsider the very foundations of our reality. Each of us is conscious. It's the most common thing in the world. Yet no one really knows what consciousness is. In this video, we will explore why our very existence represents a monumental challenge for science, an enigma known as the hard problem of consciousness. And we will see how, in attempting to solve it, we might be on the verge of the next great scientific revolution. If questions like these ignite your curiosity and you want to explore the boundaries of human knowledge, this is the channel for you. Subscribe and activate notifications so you don't miss the next journeys. Il termine problema difficile della coscienza è stato coniato dal filosofo David Chalmers. The term hard problem of consciousness was coined by philosopher David Chalmers. But what exactly does it mean and why does it put neuroscience in crisis? The main strategy of modern neuroscience to address consciousness is the search for so-called neural correlates of consciousness, or NCCs. The idea is simple. Use tools like functional magnetic resonance imaging or electroencephalogram to find which specific brain activity lights up reliably every time we experience a particular subjective experience, and we have made enormous progress. We know which areas activate when we see a face, when we hear a sound, when we feel fear. But here arises the fundamental problem. Finding a correlation does not mean finding an explanation. Discovering that the V4 area activates when we see the color red tells us absolutely nothing about how and why from that flow of electrochemical signals emerges the subjective experience, the ineffable quality of redness. Neuroscience, in this regard, finds itself facing what is defined as the explanatory gap. Let's go into more detail. The first insurmountable obstacle is the very nature of subjective experience, the so-called qualia. Qualia are the intrinsic qualities of our sensations, the taste of a strawberry, the warmth of the sun on the skin, the melancholy of a melody. These states are, by definition, private, subjective, and inaccessible to an external observer. A neuroscientist can map every single neuron in your brain while you eat a strawberry, but will never be able to measure or observe the taste you are experiencing. Qualia are not measurable. They are not physically quantifiable. As physicist Erwin Schrödinger stated, consciousness cannot be explained in purely physical terms because physics is built on the exclusion of the observer, while consciousness is the observer. Another concrete scientific problem is the binding problem. Your perception of the world is unified. You see a red, round, and shiny apple as a single coherent object. Yet your brain processes this information in different and separate areas. One area for color, one for shape, one for movement. How does the brain bind together all this separate information to create the unified scene that you experience? Who or what in the brain observes this final screen? Neuroscience has no answer. The idea of a central area where everything converges is not supported by data. Consciousness seems to be a global and distributed phenomenon, which makes it even more difficult to identify its substrate. This failure is so recognized that in 2023, the famous neuroscientist Christof Koch publicly admitted to having lost a bet made 25 years earlier with David Chalmers, acknowledging that despite progress, we had not succeeded in finding a neuroscientific explanation of consciousness. This impasse has pushed some of the most brilliant thinkers to look elsewhere, and more precisely, toward the strangest and most counterintuitive realm of science, quantum physics. The idea may seem bizarre, but the logic is compelling. The cognitive processes in our brain, at a fundamental level, involve the movement of tiny particles like ions and electrons within synapses and neurons. At this scale, quantum effects are not just possible, but inevitable. What if the brain exploits these effects? We know that quantum physics has bewildering properties, like entanglement, that instantaneous and distant connection between two particles that Einstein called spooky action at a distance. And non-locality, the fact that a particle does not have a defined position until it is measured. If cognitive mechanisms exploited these properties, then consciousness too might not be strictly local, confined to a point in the brain, but distributed and unified in a way that classical physics cannot explain. But the deepest point of connection concerns the so-called measurement problem and the collapse of the wave function. In quantum mechanics, a particle exists in a superposition of all its possible states, described by a wave function. But when we observe it or measure it, this fog of probabilities collapses into a single defined state, the one we perceive in our reality. This collapse seems to be the meeting point between the potential and the actual, but physics doesn't know why or how it happens. And here's the crucial detail. The result of this collapse is fundamentally random and, above all, non-computable. There is no algorithm that can predict it. And doesn't it seem to you that our feelings, our creativity, and perhaps our free will also have a non-computable nature? Nobel Prize winner Sir Roger Penrose argues exactly this. Free will and consciousness cannot be the product of an algorithm, however complex. They must be linked to a non-computable physical process. And the only one we know is precisely the collapse of the wave function. According to his theory, developed with Stuart Hameroff, this collapse would occur continuously in tiny structures within our neurons, the microtubules, and each act of consciousness would be one of these quantum events. The philosophical repercussions of these theories are immense. If consciousness is fundamental, then the materialist vision, according to which ultimate reality is physical matter, could be incomplete. This pushes us to ask ourselves, who are we really? Is it possible that there is something about us that transcends this single human life? It is fascinating to note how these cutting-edge scientific ideas resonate with the ancient wisdom of mystics, shamans, and sages of all times, who have always spoken of a unified consciousness and of our fundamental nature that goes beyond the physical body. Perhaps, as Nikola Tesla suggested, the day science begins to study non-physical phenomena, it will make more progress in a decade than in all the previous centuries of its existence. In conclusion, the hard problem of consciousness puts us in front of a mirror. It shows us the limits of our current scientific understanding and invites us to be more humble and open. We do not yet have a definitive answer, and it is essential to distinguish established scientific theories from speculations, however fascinating. But the journey has just begun. Whether consciousness is an illusion generated by the brain, a quantum phenomenon, or the very fabric of reality, one thing is certain. The exploration of this mystery is the exploration of ourselves. We are a universe trying to understand itself, an enigma that lives and breathes. And in this search, perhaps, we will find not only knowledge, but also a new sense of wonder, connection, and respect for the mystery of life. If this journey to the boundaries of science and philosophy has fascinated you, I invite you to be part of this community. Subscribe to the channel so you don't miss future insights. Thank you for your attention and see you next time.